So what Leventhal spent a lot of time thinking about is it that in this free energy landscape, is it that the native state is the lowest free energy, which again Christian Sandfinsen had already showed. But how does that relate to this concept if we can find that state quickly, as we talked about the last hour or so? And the remarkable result is that Leventhal increasingly realized these are two sides of the same coin. The proteins we observe, the ones that are stable, beautiful, functioning, they are so, and they have been selected by evolution because they have a well-defined native state. Remember that that was a very rare exception. And they are stable and they are able to find it because we can find it fairly quickly. In theory, if there was a native state but we could never find it, that simply wouldn't be a protein. So, natural selection would not favor it. If you think about this, if you're a skier in this landscape, the point is not that you visit every peak and every valley, but that you try to find some sort of slope downhill here, right? You avoid going too much uphill and go downhill wherever you can. And if you're lucky, you can find a funnel or a guide here. I like the concept folding funnel that guides us to the native state so that we can find it quickly. The only question is how quickly. Remember in Leventhal's, when we first talked about Leventhal's paradox, I spoke about 2 raised to the power of n, when n was the number of residues, and that was too large a number. So now I'm going to need to see if this nucleation condensation model can help us find a way around that. It can, with the help of the kinetics.